Okay, so you should be recording. Okay, so I'm gonna go ahead and introduce you, and then we'll go ahead and get started after somebody comes in. Hey, Hoda. Okay, guys, we're gonna go ahead and get started. So I have the syllabus is for today is not right. This is not workflow design. Dr. Melody Penning has joined us and is going to do a brief session on data mining today, which will pick up on some of the machine learning stuff, and she'll also show sort of some examples and some major kind of categories of problems that people approach with data mining. Dr. Penning joined the Department of Biomedical Informatics last February as an assistant professor. She received her PhD in information quality working with John Talbert at UA Little Rock, primarily in record linkage-ish. Yes, and I'll let you say a little bit more about your research interest, because part of the reasons for having all the guest lectures is that people in the class get to know faculty, so they can find people with shared interest for research, thesis, dissertation, stuff like that.
Okay, perfect. Absolutely. Awesome. And I'll be right in here. Now, when you might hear a ding ding noise. That's somebody online that has a question.
How do I?
When that happens, I will run up here.
Oh, okay. Okay, good. Wonderful. All right. Hello, everybody. So my name is Melody, and I can't wander. I was told to stay right here. First thing I did is walk away. So I've done data mining for years as a job, and finished my dissertation a few years back now. And so my interest is entity resolution. I don't know if any of you guys know what that is. Nobody? So entity resolution is when you have like a long list of customers, say, in a marketing database, and you want to find out if any of those customers are the same two people or clusters of the same two people. In the hospital situation, patients, if we had any patients that were the same and had maybe used a nickname or had a wrong social security number, we would want to link up those patients to see, make sure that we had a good solid record on them to know if they had allergies or any other kind of medical history. So that's my background. I've also worked in data mining as a job. I was a data scientist before I came here to UAMS. So data mining is kind of a two-faceted problem. We've got the methods that you're going to approach your problem with, which would be statistical methods or machine learning methods. And then you've got your tool set that you will use to address these kinds of problems. What kinds of, whether you want to get your data and then you have to manipulate your data in some way. And so the methods you're going to choose will depend upon the data that you have available to you. Does anybody have a particular data source yet, or no? Jane? No, you do. Yeah, and so you'll probably end up using a SQL database. That's what's common around here, but there's other types of data sources. We're actually going to have a meeting, a poster session on different data sources coming up very soon that you guys might want to attend to tell you what sorts of research data you could use for your own projects. And a lot of them are free sources. So anyway, you'll want to figure out your available data, the question you're wanting to ask of this data, what are you trying to find out, and how do you want to format your answer? Should your answer come out with categories of things, or do you need to add new data to the existing data that comes out? Should it be sets or patterns of information? Stop sharing it, sharing your screen. Okay. Right, so your data will be qualitative or quantitative. And I'm sure you guys know what that means. It's going to be numeric or like text type data. Numeric data is far easier to model with, but most data is not numeric. Most all of the data that you'll find is going to be your qualitative type data. So you need to learn to use that as to the full extent that you can. Your questions can be descriptive. I want to know something about what's going on right now. It can be predictive. I want to be able to figure out what's going to happen in the future. Or prescriptive. Not only do I want to know what's going on in the future, but I want to be able to change it. What do I need to do? What happens when I tweak certain other variables? Length of stay, for instance. I want to know what I can do to shorten the length of stay for patients if they don't really need to be here. So we'll start off with different broad categories of methodologies to approach problems. So there's patterns, associations, and correlations would be my first set here. And by that, we're talking about reoccurring relationships. For instance, the length of stay and the cost of your stay would be a good example. Things that occur in time together or in general. Sepsis is another good example of this. In sepsis, people come in with an elevated white blood count, elevated temperature, elevated blood pressure. These people are possibly septic patients. Now, there's a lot of other patients that are going to meet these same criteria too. If you've broken your leg, you're probably going to have some of these same issues. So you have to determine which of these associations would be interesting. Types of these pattern mining methods are linear regression. Bigger houses cost more, right? That's a very simple linear regression problem. Or frequent item sets. My data mining teacher's favorite set was beer and diapers. Meredith, yes, you have a question? They sure are. Oh no.
Okay, hang on. Something's not working.
I presume they were showing the wrong.
Okay, so
I'm
guys.
sorry, am I talking too fast? Tell me if I'm going too fast, okay, you guys?
Guys online, can you see the slides?
I'm glad you noticed that, Meredith.
I'm sorry it took me so long to figure out, wait, this is something that was on her slide.
Yeah.
Okay, so they can see them online.
Oh, they can. So you guys just log in.
Okay, guys online, hang out a second and I will figure out what in the world is not working up here. Do what now?
You know how to fix? Oh, good. He knows how to fix it.
Should we just, like on my Mac, sometimes if I unplug that and plug it back in? So she's sharing in Blackboard.
Okay.
It's not coming.
Yeah,
It's her like mirroring or not screen display thing.
Let's just say it's oops, not this one.
Yeah, see, I've got it set for multiple screens. I bet that's what's going on.
Oh,
Yeah.
yep, that's it.
So choose duplicate this.
Yeah, that's
Thank
what we
you,
want.
Jan.
I think that's. Yay, Jen, thank you.
Thank you very much.
Keep it check.
Okay, sorry, guys.
Okay. All right, let me see if I can figure out. Oh, I was telling you guys, my data mining teacher's favorite frequent item set was beer and diapers. People would go to the, as far as marketing, right? People study like Amazon. Have you ever noticed when you're on Amazon, it offers you other things to buy when you're buying something? Well, there was a study done, and apparently beer and diapers was a very common occurrence for people. I can't remember if it was Walmart or Target shoppers. There was another study where there was, I think it was Wisconsin. There was a young girl that had gone to Target and had made several purchases, and all of a sudden Target started sending baby ads to her family's address, and so they were kind of offended. Why are we? Because their neighbors weren't getting these same ads, and as it turned out, Target had done some data mining on her and had determined that she was pregnant, and they were right, and her parents didn't know. So So yeah, it's amazing what you can find out with just a little bit of data mining. Eye color and hair color would be another thing. There's things that vary together, and then there's things that vary in opposition. I don't know if I've got a good example of things that vary in opposition. Yeah, I don't, but obviously there'll be some attributes that as one thing grows, another will decrease. Can anybody think of an example? Absolutely, that's perfect. Thank you. Yes. Sunscreen and snow boots for you guys online. I know you couldn't hear that. Okay, so the next category of methodology to approach problems would be classification. And this is an attempt to label something as a particular predetermined class. Again, the sepsis model is a good example here. You can take different ranges of values, say for white blood count or temperature, and you can plug all these values into logistic regression, and you can get a probability that someone might be likely to develop sepsis. These models that you use in logistic regression or some of our other types are learned from training data. So in order to build one of these, you have to have a set that's already done, a data set that's already done with the attributes that you're interested in, as well as the class label, these predetermined class labels that you want to claim that you're looking for in the future for new data that comes in. So some examples of that besides logistic regression would be like a rule classifier. So you could say that if you were marketing, for instance, you could say that everyone above a certain income, but with a certain type of car, I need to target them to buy also something else. Or taxonomic rank, for instance, also uses is a classification. All furry mammals with 4 feet and these kinds of toes fit into this particular type of classification. So clustering is another methodology. And to do clustering, that's entity resolution, of course, is my favorite problem. This is what I did my dissertation work on. And what you're looking for is common characteristics to group sets of data on, and you don't need labels to do this. You don't have to decide ahead of time what the clusters will be. In many cases, you will decide how big the clusters might be. There's some tuning that takes place, but they're attributes that, say for instance, in entity resolution, you group a set of names based on the first name and the distance between that and another, like a nickname. So how many characters it has in common is called the Levison edit distance. And you would use also like a social security number and a phone number, and these would make clusters of people that you could use to decide that this was the same patient in the hospital, for instance. Or there's also DB scan. So if you were interested in imaging, you might want to pull up an x-ray and use this to look for distinct areas in the x-ray that were different, that stuck out from typical x-rays in order to determine people that had tumors or other types of problems. So those are your broad groups of categories of methods. And these methods, there's so many of them that we really can't talk about any one specifically. It would take, there's classes, there's long lectures on each specific method, and there's lots of different methods. And to do these methods well, you have to really understand not only the data that you're putting into the method, but how the method itself works, all the assumptions that are involved in the method. Any failure to meet the assumptions that are in logistic regression or linear regression or any of these other modeling techniques will result in, and you may get answers, stuff may come out of your model, but it is not likely to be real answers. So you'll have to take the time to figure out what your problem is, and out of all the possible ways to address it, what's the best way for you to figure out to approach this problem. Okay. So now we'll be on to tools then. Lots of different tools to get at the data. Typically here, SQL is your first plane of attack because it lives in a Microsoft SQL database, and you have to be able to get it out to look at it. And that's the case in lots of places. Sometimes you'll be given data that comes in a CSV and you won't have to pull it out yourself. But SQL, you can, if you've got access with SQL, you can also do some processing with it. Once you have data, you have to explore the data, right? You'll have to clean it and explore it. But before you even decide what to clean, you've got to look at it to decide what is in the norm. Are there outliers? What is the profile of my data? Is there columns that are just empty or populated with values that don't make any sense? Until you know that, you can't, again, if you use your data without understanding it, then you may not get the kind of answers that you want. And Tableau is I like Tableau. There's lots of other tools out there, but Tableau is a visualization tool that you guys can download for free as students. And it's very pick and pull. I don't have it open right now, but I could if you guys, maybe at the end if we have time, we'll open it up. It lets you bring up a data set and you can pull different fields into an area, and so you can see how the data relates to different aspects. So you can get counts or interactions. It lets you know if there's something odd going on. R, that's my favorite, is good for data wrangling and statistics. You guys know what data wrangling is? No? Data wrangling is taking big bunches of data and changing its form. Gathering it together or flipping it around. Sometimes you have things in columns and you wish they were in rows, or sometimes there's one particular class of things that you need to, instead of having it listed as whatever that class is, you need to bring it up and make dummy variables. I don't know, you guys have probably had statistics. So SAS is another product just like that, same sort of thing. SAS is proprietary, aka expensive. So you can use it at the institution, I know, or if you work at a place of business that has SAS. And it's more for just statistics. It's not really a very good data wrangler, at least not in my experience. Although Axiom uses it for that. Python, also a scripting tool for data wrangling and manipulation. Weka is a tool that has different types of machine learning technologies within it, and so you can pull up Weka and use it to do classification and clustering and frequent item sets. It's all built in within the system. It uses a different data format than most other tools, and so you'll have to be able to change your data into the format that it wants to consume in order to use this particular tool. But it's nice because everything is built in together. And so most of these tools that I mentioned work on little data sets, which is fine. And by little, I mean a couple 100,000, depending on the machine you run it on. But if you want to run a lot of data, Hadoop is a much better choice, or a high performance computer if you have access to that. And Hadoop, for those of us that don't, is a great tool to manage a lot of data that attaches to many of these smaller tools. And we'll talk more about that later. So SQL, you need to have it. Everything's typically stored in a relational database, or most of the time now. It may change in the future. People are trying to go to NoSQL. I understand you guys have had some SQL already, so you understand how it works. It's not very versatile. It comes in proprietary flavors. If you're using Microsoft SQL and then you get access to an Oracle database, the SQL's not, I mean, it's close. It's very close, but there'll be things that you can use that you can't use. Mostly it's in Oracle going back. There are tools in Oracle that you can use, syntax tools, that you can't use in Microsoft SQL. Lots of people can do wonders with SQL though. I've seen people that can write SQL that is just absolutely amazing. You have to practice at that, and you have to really spend some time with it, but it's absolutely doable. It would be my suggestion to add some other tools as well. So small jobs, which is what we're talking about, the smaller data sets. R, SAS, Ruby, Python. So R, which is my favorite. It's you see the Swiss Army knife? That's about what this thing does. You think of it and it can do it. It runs on any platform. It's got a huge active development community. It's very popular in education circles. So there's constantly new packages being developed to do new and interesting things. Another reason I couldn't cover all the methodology possible, there's 4,000 plus packages to do 4,000 different methodologies in R. So, and the graphics are really good. They're for free. It's amazing. And this is a free tool. It has a SQL package as well built into it. It's comparable to SAS in quality, but it's not as fast. Everything's got to be pulled up into memory in order for it to work. Now, I don't know how SAS works behind the scenes, but I know this is how R works. So I have a little example here on R and SAS. So this is an old simulation experiment. Let me go back to the slides for just a second. So this is a simulation example where we're basically approximating pi. But there'll be lots of situations where if you simulate some data, you can get a head start on your project. And so data simulation is probably something that you guys will see at some point in your careers if you stay in the informatics area. So this one is nice because it approximates pi, so you know if you're doing a good job. So this is the code part that actually runs Buffon's needle, and I hope I'm pronouncing that right. And this is the part that calls it. And so I'm going to run this, and I'm doing 10 needle drops. And so the idea is you drop a needle over and over to get your data set. And within R and SAS, there are random number generators. And so this will generate sets and mimic dropping needles to come around to get our probability that we're showing right here, where pi is approximately equal to 2 times the length of the needle over the distance between the wood planks times the probability. So, and you can see that's not exactly pi. It's going to kind of jump around. And this is, again, 10 needle drops. Let's look at it in SAS, which I seem to have lost. There it is. Make that a little smaller. And again, we're getting numbers that are not exactly in line. So let's change this 10 needle drops to a bunch more. Our number should be much closer to pi. And we could look at all these, every one of these outcomes if we wanted to, or in our case, like I said, we wanted to just look at the one summed up result. And here, you see, the answer is much closer. Let's look at it in R. Now, when you do 300,000 in R, notice that was still pretty quick though, right? Let's see. Can't see what's going on. Still only doing 10. There we go. Now look how much longer it takes to run it. This is because, like I said, R runs everything resident in memory, and it's got to make all these calculations and churn to produce the answer. And it's probably not as optimized as SAS, but it's still my favorite tool. It's free. I have no idea how SAS works. I did this experiment just to figure out, because I was trying to crunch a lot of numbers, and R, even though it's my favorite tool ever, it was just not getting it done. And so I was trying to figure out why, and I'm assuming that it's the memory issue.
My guess is yes, because back when Jim Goodman started developing it, back in the 60s, way back when, like Fortran was the language here. So I'm thinking that it probably still has the use of that architecture there. But that's just a guess.
Yeah.
They certainly have a ton of money, so maybe it's the architect just didn't have the same thing. That's right, exactly, that could be.
So,
I used to live like right behind the SAS campus.
yeah, SAS is very cool. Okay, so Python, Ruby, other tools along these lines, and there's lots of different tools. They all work great. Everybody's got their own favorite. Amazon uses Ruby. I don't know what possessed them to decide on that. Python is a good tool. Lots of people like it. Oh, and here I'll show you Weka. So Weka, W-E-K-A, is a data mining software. It's written in Java. It's free. And you can go out here and download it. Download the also the requirements and the documentation. So you make sure that you've got it set up properly on your machine. And again, once you get your data into their proprietary, or proprietary is not the right word, but the required setup for what they need to process, then it will do classification and clustering and pattern mining, and it's really very handy. And also, it is their claim that Weka can also be used for big data now as well. Now, I haven't experimented with that, but that's something you guys can go on and try if you're interested. So what it comes down to is pick something that you like, that you're comfortable with, and you don't have to know everything. It doesn't matter if you're comfortable with a full set of tools. If you are, that's great, but you don't have to be. So, but big jobs require more processing power. So we'll talk about Hadoop. You guys know what Hadoop is? No?
We haven't covered it in class.
Okay. So Hadoop is as an environment where you run the MapReduce model. And so the MapReduce model is very simplistic steps that you combine in order to do really big projects. And you do these simplistic steps with lots of machines in parallel at the same time in order to manage big chunks of data. And the famous example is the word count example, where you go through and you pick out all the words in a piece of data, a piece of text, and tally up the comes in 5 times and cats come in 3 times. And so you're just counting the words. But this particular programming model can be used to do many other things. Not everything, but you can squeeze lots of problems into the shape of the manipulate, sort, and filter model, which is what you do with MapReduce. And here's an example of it. It's kind of small. Let me see if I can get that a little bit bigger. So here you can see we have a couple of mappers, which are machines running software. The same input stream comes in and gets parted out into, here we're only showing 2, but there'll be as many machines as you want to buy or use yourself. And it takes each of these sets of data, breaks it up for all these machines to work on at the same time, and then you do whatever kind of processing you want. In this example, there are sentences in English and German which have been broken up into little 2-gram components so that they can be counted for natural language processing reasons. And I'll show you an example of those here. And so here's input 1 and input 2. There was 2 different files. I guess I'll pull up the English one. Well, okay, so that's English and German. You can see it's just plain text. You could imagine doing this with notes out of the EMR, doctor's notes, that you were interested in finding out, say, cancer information, right? You want to classify the cancer as to what level what stage that they're at. And so that's a hard task. There's lots of people actually working on that very task based on what's the data that's in the notes. And so, go back to the slide. And so you break them out into smaller components, in this case, 2 grams, and you move down into your sort, where you, after you've got the 2 grams, you put them in alphabetical order. I mean, sorting can be whatever you imagine it to be. It can be sorting by numbers, it can be sorting by letters. And then, you feed it into your reducer, which is just another piece of code that takes, it's not going to let me do that, is it? That takes all of the common things and sums up your answer. There were 2 cases of DE in that, there are 2 cases of the German version that had AB. And you can go up here and you see, I don't know if they've got it in the example. But I can show you in the actual file. So for example, let's find a good one, AL. So in input 1, it is found, now this is a count of only the German version up here. That's found 6 of them that are German. So let's look at the ones that are German. 1, 2, 3, 4, 5. So let's see, if things are right, then when we do a search on this one, there'll be only 1. And there it is. So this is the very simplistic function of Hadoop. It looks like nothing, but you can do amazing things. We've done entity resolution using this programming model. Now, it was hard to fit it in to that particular arrangement. You have to really, really think to get your problem to fit into this particular programming model. Now, give it back. Okay. All right. So Hadoop is only software. It has to be run somewhere, and you've got choices on where you want to run it. You can run it in virtual machines, and you guys know what those are, right? Yeah. And you can run it on real machines if you happen to have a lot sitting around. I know a guy at Axiom that did that. He happened to have a bunch, and he built his own parallel computing network just for fun. Or you can rent some from Amazon. It'll be, or Microsoft Azure. I don't want to slight Microsoft there. They will sell you instances of machines that you can do parallel processing on. The cost varies. If you want little machines, that if you're talking about the virtual machines are free. But if you're talking about Amazon or Microsoft, if you want small machines that don't have a lot of processing power, but since you're doing them in parallel, it doesn't matter a lot. You can get those even for free, some of them, when you initially sign up for Amazon Web Services. The bigger ones to do that have more memory or more compute ability are sometimes expensive, and they rent them out per. It's a compute hour, and I don't really know exactly how they calculate that, but you have to get an idea of how long your process is going to take if you're going to rent a big expensive machine to do, or several of them to run in parallel. So virtual machines. Virtual machines, you guys are already aware of. They come in different flavors, but you can get one already set up with Hadoop on Cloudera. So you can go out to Cloudera, and you can go to Downloads, Quick Start VMs, and here you can pick out whether you want VirtualBox, VMware. When you download that virtual machine, it comes to you ready to do Hadoop. It's got everything. Now it's going to do Cloudera's version, right, with the Cloudera front end, but Cloudera is really very nice when you're first starting Hadoop because it's very much more interactive. The Hadoop software itself is harder to understand from the ground up. This gives you sort of like a Windows operating system. You can look at it from the outside in, and you don't have to know a lot. So it's a very handy way to start. Or you can get your own virtual VMware, VirtualBox. I used VirtualBox. And that, once you do that, if you want to set up a virtual machine, you can go out to the Giraffe site. It's the Apache Giraffe site. And here, sorry for making you guys dizzy, here it will tell you first how to set up your virtual machine to do Hadoop, but then also every little step, I'll go back up here to the top, every little step that it takes to install your own Hadoop system on your virtual machine so you really, really, really understand how it works. If that's something that's interesting to you and you want to be able to process big data and you want a free test environment on your own machine, you don't have to do Hadoop in a multiple environment. You can start it off just doing it on your own machine. You can build even several little VMs and hook them together on your own machine just to get an idea of how the thing's going to work. Depends on how serious you are, but this is the best tutorial I've seen on building up a system for yourself.
Can I say something real quick?
Absolutely.
So you might have to repeat it to the folks on the mic in here, but it might seem that this is not relevant to you as a researcher, but I'm going to use, just now I'm going to use David's group. When David came, there really wasn't a high performance computing set up here that he could use. And he had to work with other people, and Dr. Tarbox, who was earlier this week and the end of last week, to actually buy all of the hardware and set up a high performance computing environment. Now, they didn't do Hadoop. Theirs is a little different. But as a researcher, if you go somewhere and the computing resources don't exist, you are pretty much stuck unless you can do it yourself or find somebody that can do it. Which is why we sort of cover the variations here, because you need to know when you need a parallelized environment and parallelized software or not, and vice versa.
So, okay, for you guys,
That for people online.
exactly. So for you guys online, Meredith was just letting everyone know that this will be valuable for you guys as researchers, since you won't always necessarily have access to a high performance computing lab or parallel computing such as in Hadoop. When Dr. Usry and his team came, they didn't have these things. They had to work very hard and for a long time to get theirs set up and available. So the ability for you to go out and set up your own, did I get it, Meredith?
No, you're good. Me and Caleb were just talking about it, still not exactly working.
Well, I wasn't going to say that because I figured you'd be mad at me if I said that online. So, okay. She was mentioning that they're still struggling so to get it up and going. So even more supports my point that being able to do it yourself is, well, not only does it give you a better understanding of what the heck's going on, but also it lets you do a little testing on your own where you're not dependent upon someone else that's got a broken machine for whatever reason or whatever else is the matter. It lets you experiment. Now, we'll say, having said that, even when they say it's the same environment, Hadoop here on the virtual machine and Hadoop there on AWS or Hadoop there on Microsoft Azure, it's sort of like SQL. There's little tiny differences. And so when you pick your code up from one place and put it someplace else, maybe going to have to tinker with it just a little bit because it's not always, nothing's always the same. So there'll be minor changes. I would expect that. So Hadoop is a system that you build it out on your Linux VM, and the commands that you use within Hadoop are very Linux-like as well. And so you don't have to know a lot of them. You need move and copy and delete. So you don't have to be a Unix guru, but you will need a little bit of that sort of thing in order to manage it. You can monitor the jobs as they progress by using a browser, which can attach into the software that's running, or you can watch it through the command prompt. It will show you how it's processing in the VM or in the case of AWS or MS Azure. So my slides look like they're out of, there we go. So we talked about the VMs. This is the one that you can purchase, the AWS model or the Azure, and they'll let you buy on-demand EC2 machines, and those are just compute machines. They're just like a regular computer. I'm sure they're virtual machines, and you just rent them. You can scale them up in real time. You can keep them permanently if you want to pay for that. It also has storage available for you called S3. Let's see, and I can show you all of this stuff. So some of the services available on AWS, and you can get a free account. This is the S3, which is just like a big hard drive. It's not, you have to give it a name, and the folders, they call them buckets, but they're just folders. And then you build your own folders. This is what I wanted there. And this is the setup that you use for Hadoop, input, output, and scripts. Output 2 was just me playing. I'll also show you the EMR, which is the Elastic Map Reduce. That's AWS's terminology for it. And here you create clusters. So we'll look more at that in just a minute. MS Azure is like all Microsoft products, much more point and click. I don't have a demo for that because that's not the one I use. But I think it'll be very friendly if you chose to use that as opposed to AWS. You can SSH into these processes, these EC2 machines, and using PuTTY or MobaX, and watch your processes and move your files from your own machine up to the cloud, back and forth. MobaX is really very handy about that. It lets you actually just pick and pull to move files back and forth, which is handy. Again, cost is important if you're having to do it on your own. VMs are free. Amazon and Microsoft both have a free tier, but then it can become very, very expensive if you start a big, long process, and especially if you forget to terminate the cluster. The clusters can run on forever if you don't shut off the lights. So you need to always turn it off when you're done. Software options. Okay, so Hadoop comes out of the box built with Java. It has Hive and Pig and things like that come with the Cloudera version and the AWS. And Hive is like SQL. So it gives you a SQL-like language that you can use to query your results from the HDFS, which is your file system that Hadoop uses. I can't remember what the acronym stands for. High density file system. I'm not quite sure. I have to look that up. But so those things come as part of the Hadoop system. But you can also use other tools like R or SAS or Python or just about anything else, and use Hadoop as your backend to do your data processing. And so I have some, this is called streaming, and so you set up Hadoop to incorporate other processes into the job. And so I have some examples of that as well. So here's a MapReduce that I found, just an example of, that you can run on Amazon EMR. And this is the one that I was showing you with the word count. You can pull it up and run it yourself. It's got all of the code that you would need. It talks about the mapper and the reducer and how you can implement them on Amazon. I will show you that. So this is the cluster that I built out. Can't really see. And here are the steps. And so I had a failure on one of my steps on the reducer. I don't know what's wrong with that, but the steps are pretty straightforward. You can, let me see. I'll go through and I'll just show you how it sets up. So all I did just then was to copy all the work that I had done before. We'll start with the software setup. You'll come out with quick options are your first setup, and that's if you just want a cluster without making it custom. I wanted to make a streaming cluster, so I'll go to the advanced options. I have to pick, it's gonna break. Oh, there it comes, okay. So I've got to have a version that works with R. So I will use the AMI version. There's lots of other versions of Hadoop that you can pick. It's very, very customizable. And I wanted to do a streaming stepped version. So I'll configure that. You see this is not complicated. I have to have the mapper, the reducer. These are just little bits of R code like I was showing you with Buffon's needle. They're, again, not difficult. This is the input directory, and then you have to tell it the output directory. When you tell it the output directory, it can't be an existing directory. It has to, Hadoop wants to write that out. So if it's one that exists, it will fail. So delete that before you start. Action on failure, terminate, or unless you're going to watch it, then you can come in and terminate it by hand. My next button is hiding. This lets you pick your machines. How much a machine do you want? These are M3 extra larges. It starts all the way down, and you go out to Amazon to find out the different size of machine to choose. The machines are based on compute power and memory, and they've got a whole lot of different options because people need different types of machines for different reasons. So the cheap ones, M1 large. We don't need a task. We just need the two. I want to see logging and debugging. Termination protection stops you from being able to turn it off. Don't need that. I want to be able to turn it off. Bootstrap actions. What do you need when you start your cluster? Well, for this one, I need R to be installed, and I need a particular package in R to be installed called stringdist that will help me to break up everything into little 2 grams. And so here in the Bootstrap, I will select a custom action. I will go to the scripts area, and there's a little Bootstrap script that I've written that holds the commands that call out to CRAN and to get this particular package uploaded into this computer that's living in the cloud. Now I've got all my options set. Security, if I had some data that I was concerned about keeping secure, I could set up security. As a matter of fact, last I checked, there was a region even where DARPA was allowed to use through the government because they had set it up so secure. So I believe that at some point we'll be able to use healthcare data if we can't already in the cloud. I don't think that we can here at UAMS, but I think that that will be a possibility. And so it takes forever to start up a cluster, so I'm not going to do that. It takes 20 minutes just to run even a little job. So when you do it, you want to make sure that everything's ready, and actually bigger jobs would be better because it's going to take almost as long. The time with these things is mostly getting everything up and going. So that's neat, but what's even neater is the fact that you can use RStudio, this little thing that I've been going back and forth to process, and as well as SAS and any of the other tools. Again, I'm kind of an R fan, but to go in and use Hadoop as your back end and process data directly, holding the instances up, and do things like this. They've done this. This is an example on AWS. You can follow the steps and do it yourself, where you can process large amounts of data in an interactive fashion. Instead of mostly Hadoop, you put all the data out there and you put all the file folders out there and you go and then you sit back and wait for it to cook. In this kind of setup, you can put everything out there and then you can play with it. Well, no, I want it this way, or no, I want to change these things. That's very, very awesome and handy because you can change it. You don't have to, you're not just trapped out here tapping your fingers, wait for it. So that's a pretty awesome new development. And so, questions then, online or out there? None? You guys already know how to do all this stuff?
So I would like to go back to the sort of three approaches
Okay,
and talk through an example of an informatics problem or two.
okay,
that would utilize or require each of those approaches and see if we can't do that across some of the different application areas in the discipline.
okay, so in we've got three major categories. We've got patterns, associations, and correlations. Be our first one. And so to look at correlations or chi-square tests of association would be something that, for instance, in EMR data that I can think of right off the bat, blood pressure, that's something that comes to mind that's numeric, right? And temperature, or I also think of the length of stay study. Let's see. So the longer you're in the hospital, the larger your cost would be. That's a correlation measure. Attributes of your patients, hair color and eye color, for instance, tracked together. That would be the chi-square test for association. So Meredith has asked that for examples for you guys online, of patterns, associations, and correlations, as well as the other is classification and clustering. So can you guys think of examples, Meredith?
So say the CEO of the hospital comes to talk to us, and he would like to know, he says our length of stay is longer than other people's. Why is that so?
So why is the length of stay longer?
Yeah, which of these methods would we want to use to try and get at that? So, okay, if the CEO of the hospital comes and says our length of stay is longer than the national average, I want to know what contributes to that. Why?
So if the CEO comes and asks, why is our length of stay longer than the national average? How can we address that question?
We have to look at how our inpatient population is differently the same from other populations, to characterize our population, and look for associations between people who are in our patient mix and their length of stay, and then compare. So we're associating different characteristics within our population to their length of stay.
So if he wants to know why we're looking for patterns in the data. Yeah, so if he wants to know why, so is that something we might use a clustering for, or is that something where we might use a correlation for? Like if we have no idea about it, okay, we go and we just take a look at the data and we say, well, since I have no idea, I'm going to pick the 100 data elements, the broadest group of data elements that's reasonable that I can get. And I want to mine out and learn from the data what aspects of a patient's characteristics or their care are going to impact length of stay. Would I use a clustering method, or would I use more
Of a classifier or a correlation? What would be the best method if you were trying to answer this question? Online people.
What is the specific, I mean, is it just in general?
So that's it. When people are data mining, that's how they approach the data. They don't know. They might know something operationally, like they say, well, daggone it, every time I send them for a CT scan, it takes them an extra day, I swear. And they might have that idea, but they want to understand, what does the data tell me? What is in the data so you're looking for stuff in the data. So if you did a correlation, if you just started looking for different correlations, that'll tell you what's associated with length of stay. So if you ran over 100 data elements, you would get a correlation coefficient for each data element. Okay, that's a lot. Yeah, that's a lot. So maybe we might then come back we might look at that and say, well, okay, turn the ones red where it's a high correlation. Then we might start clustering ourselves, or we might look at the data and say, is there a way to model this? You know, now that I see what the high correlation things are, maybe I only care about the top 10. And I'm going to go back and I'm going to write a linear model, and I'm going to go get the data again with some type of a general linear model routine and look at the correlation. So that's one way, right? We can approach it as a correlation problem. But what we miss in that, unless we ask the computer to do cross correlations, which if you have 100 data elements, that's huge, to look at the interactions between the data elements. We're going to miss some of that when we do that data mining in that gross way that I just sort of laid out. If we do some type of a clustering method, I think of principal components as clustering. Probably not everybody does. But if we wanted to do a clustering, then we're asking the computer sort of a different question. We're saying, which of these things kind of go together and are co-responsible for increases in length of stay? So when I mine out that way, I might get a thing back that says, well, socioeconomic status is associated with it.
So Meredith is suggesting clustering for you guys online might be a better approach than correlation, since correlation is such a blunt tool, right?
So if I approach it by clustering, and I let the machine cluster for me based on it's looking at correlation, cross correlation, whatever, then I might get little groups of things that ride together, like lower socioeconomic status or people without insurance, which might correlate with that. Something that other stuff might also correlate with that might be social aspects of characteristics about a person. I'm sure there are probably other stuff. So when you start asking for clustering, you're looking for things that are going to covary together, and you're lumping together sometimes things that are possibly confounding each other, things that are correlated together. So you're looking above that and getting clusters. Now the cluster might be wrong, you might not have that correct. It might just be that it went in there numerically, but clinically it doesn't make sense. So what I'm kind of getting at is this is a different hammer.
You could also use that as a classification problem. You could label your length of stay, everybody that's had a length of stay over 100 days. I'm labeling that as I don't want that. That worries me. And then you could class label each group and stratify your groups that way, and then run a classifier like logistic regression on them. Then you can include lots of data types, and it will tell you what it likes and what it doesn't.
Is that sort of making sense, kind of differences between them? So, how would it work with a dichotomous grid?
Well, and that's if you're going to use numbers, you can use linear regression, lots of things. And that's why I said logistic regression, because then you can have you can throw all of it in there and it doesn't matter. I can have all my categorical variables that are, race and hair color and whatever I want, and blood pressure, and the whole business can go in as a heap. Or if you've got ideas, then you can, separate these out into specific different kinds of calculations.
So, but if the variable, if the dependent variable was the highest, then classification would that help? I mean, depending on what you're classifying by, so you're classifying by a high length of stay.
Right.
So classifying by dead or alive wouldn't.
That's equally good. You can do either one of those with just a classifier. Absolutely.
So do any of you guys use any of these methods today in your work that you do? Does anybody think you're gonna do a dissertation that might use some of these methods? One? So I'm not gonna quiz you on these because without providing statistical background, the questions just aren't very meaningful, frankly, that we could ask. But we didn't want to not cover it. Some intro classes will pull out Weka off the web and have you do a lab in Weka, actually do some data mining or machine learning. But as Melody pointed out, that degenerates into garbage in, garbage out really quickly, unless you really understand the statistical model. So, for those of you who aren't going to do stuff like this, you don't have a very big need for those types of statistics. For those of you who are going to do it, you're going to have to be expert in those types of statistics. So it's not something that we want to make everybody have to spend. This is like you can take a whole course in data mining. You can take another whole course in machine learning, and then just be at the intro level.
Yeah, absolutely.
So that's why we cover it like this, but we didn't want to blow through it without at least thinking through some of the methods and introducing some of the different approaches to data mining. Anybody have any questions, thoughts?
Online, you guys? I don't know how that would know if they were talking anyway.
It would ding.
No. Oh, that's right. So,
Okay, guys. It's probably not worth going into the next lecture with 20 minutes left. And also here, let me go there.
Okay.
So I'm going to be out next Tuesday on the road. So do not come to class next Tuesday. I will also post an announcement on Blackboard and send an email out. I'm going to just record the lecture there. It's on the lecture Tuesday is going to be workflow analysis stuff. So it's basically how to draw the flow diagrams and the data flow diagrams that we glazed over earlier when we did some in the first week or two of class. These are the data flow diagrams are not really in the UML. Activity diagrams are similar to flow diagrams in the UML, but it's a different notation, different symbols than UML. And so since flowcharts are used so ubiquitously, we want to make sure that we cover that, and then everybody can do a proper flowchart. So that is going to be the lecture for next Tuesday. Next Thursday is going to be rules-based systems. So procedural knowledge on the syllabus, knowledge of process and decision rules. So we're going to cover both of those next week. There will not be a quiz on this. I will make you guys a quiz on Dr. Tarbox's stuff, the intro to computer science type stuff. Okay, does anybody have any other questions? Anything else? Okay. Okay, so I thought I had posted Tuesday, but let me check. There's something can always go wrong. Can I just close out, Melody?
Absolutely.
Is that okay?
Yeah, you can close all that out too. You
Okay.
wax that whole window.
You sure?
Yeah.
Okay. Oh, there we go. Okay. All right, so let me go out to course materials. Yes, I'm trying to learn how to scroll.
You can use the little pad.
Oh, all right, they are not there. Okay. All right, so I owe you guys lectures. I thought that I had posted Dr. Tarbox's, but evidently not. It is not here. So Hoda, thank you. For okay, hang on, let me go back. So week 10 too. Okay. Okay, let me go back. Let me find those before I'll log in on that machine and find them before I leave. Anybody else have any other questions, challenges? Okay, have a good afternoon, guys.
Bye, Emily.